Software development is a complex activity. Requirements are collected from users and analyzed to create specifications of what the software is expected to do. Programs are designed and coded to satisfy the specifications and then maintained after they are delivered to the customer. The life cycle of a program also includes testing and debugging phases. In fact, there are many development activities that can produce executable programs of one sort or another. Prototypes, specifications, and designs all may be targeted for testing. The purpose of testing is to find program failures. This is harder to do within an enterprise application in a remote and/or concurrent environment. So we have a software fault, a defective, missing extra instruction, or a set of related instructions that is the cause of one or more actual or potential failures. We've got debugging, which is the process of locating and correcting faults. A deadlock is a state in which each member of a group is waiting for another member, including itself, to take action such as sending a message or more commonly releasing a lock. We've got a live lock, which is a state which is very similar to a deadlock, except the states of the process involved in the live lock constantly change with regard to another or non-progressing. Starvation is a problem encountered in concurrent computing where a process is perpetually denied necessary resources to process its work, and then a race condition is a special condition that may occur inside a critical section, leading to storing mixed condition statements of the data point. For native debugging, kind of like right here on your machine there, bud, native debugging is the classic style you're running the Java program locally. No framework, nothing extra, no tricks, and you're using, in our case, the IntelliJ IDE built-in debugger to set your breakpoints, step through your code. You can use F7 and F8 as your shortcuts. Watch variables and method calls like a hawk. When you're building and testing locally, trying to squash bugs in your core logic, or just want to figure out why 5 plus 10 suddenly turns into 50. Remote debugging is whenever you connect remotely using JVM. With remote debugging, you launch a Java application with special JVM flags so it can listen and it can watch. You attach the debugger from IntelliJ or another IDE. This tells JVM to sit politely and wait for IntelliJ to say, hey, I'd like you to take a peek right now on what's going on. So you're going to use it when your app runs on a server, Docker container, or a virtual machine. You're dealing with startup bugs, or you want to debug from afar, like you're traveling. For your concurrent debugging, that type of debugging deals with multiple threads running at the same time and trying to catch all the bugs, like your deadlocks. Two threads politely waiting on each other forever. Race conditions, two threads racing to change the same value. Starvation, where one thread hogs all the resources. In IntelliJ, the threads view is your best friend. You can see all the threads, pause them, and check who's holding what lock. So you're going to use this when your app has multiple threads or background tasks, or you're seeing weird behavior that only happens sometimes, usually when you're trying to give a product demo.